So here we have a very basic question from the topic of work, power and energy. Let's see what the question is and try to solve it. So they have given that a body moves a distance of 10 meter along a straight line under the action of a force of 5 Newton, and they have said that the work done is 25 joules, and they're asking us to find the angle between the force and the direction of the motion. So from the given question, the first thing that we can realize is the force is constant, and we can use the formula directly for the constant force, work done by constant force, which is Fs cos theta. The work done is given to be 25 joules. The force is given to be 5 newtons. The displacement is 10 meters, and they're asking us to find out the angle. So it comes out like this: 25 is equal to 50 times cos theta, and 25 over 50 is coming to be cos theta. We know 25 over 50 is 1 over 2, and when cos theta is 1 by 2, we know that theta is nothing but 60 degrees. So the correct option we can clearly see is option 3, which is 60 degrees. So this is the next question, a basic type of question from the topic of work, power, energy. And it is given that a body is constrained to move in y direction. A body is constrained to move in y direction. And it is subjected to a force of 2I cap plus 15J cap plus 6K cap Newton. And they're asking us to find out the work done by the force, by the given force in the question, when the body moves a distance of 10 meter along y-axis. So when they are saying that the distance moved is 10 meter along y-axis, it means that displacement is 10 j cap. The displacement is 10 j cap, 10 meters displacement in y direction. So we are adding a unit vector of j cap. Now the force is a constant vector, so work done is Fs cos theta, and which is nothing but the formula for the dot product, F bar dot S bar. So work done can be written as Fs cos theta or F bar dot S bar. And if we dot the given two vectors of force and displacement, this is what we are getting. So we have 2I cap plus 15J cap plus 6K cap dotted with 10J cap. Now the dot product always acts between two similar unit vectors, because we know I dot j is 0 and k dot j is 0 because they are perpendicular to each other. So the only thing that remains is 15 j cap dot j cap, 15 j cap dot 10 j cap. 15 into 10 is 150, and j cap dot j cap is 1. We are finding out the work done, so the unit is obviously joules. So the answer comes out to be 150 joules, and the correct option therefore is 2. So the next question that is given to us is: a body of mass m is tied to a string and is lowered with a constant acceleration of g by 4. The distance traveled is vertical and it is downward because the string is lowering the mass, and the distance is h. We have to find out the work done. By the string. Work done by the string. So they are asking us work done by the string. First, let's draw the diagram. So we have a string over here, and let's attach a mass to it. The mass is m. First, let's draw all the forces on the string, on the mass. So downward we have mg, upwards we have tension, and there is an acceleration, downward acceleration of g by 4. So as we can see, all the answers are in the format of mgh. We have to find the tension in the form of mgh. Now why do we require tension in the form of mgh? Because the question is asking us work done by the string. So obviously they are asking us work done by the force in the string, and the force in the string is nothing but tension. So we have to find out work done by tension. So I'm writing down work done by tension as Wt. So work done by tension will be tension into displacement, that is h, into cos of theta. Now, the tension is upwards, displacement is downwards. So obviously the angle between them is 180 degrees and the answer will be minus TH. Minus TH. The only thing now remains to do is we have to find out tension in terms of mg, and that can be done easily by using NLM equations. So if we write the equation for mass m, downward force is mg, upward force is tension, and the acceleration is in downward direction, therefore mg is positive and tension is negative. So net force is equal to mass into acceleration. Mass is m into acceleration, and acceleration is g by 4. So mg minus mg by 4 is equal to tension, which gives us tension as 3 mg by 4. 3 mg by 4, and we just need to substitute the value of tension over here, and that gives us the answer minus 3 mgh by 4. So this is the work done by tension, which is nothing but the work done by rope in lowering the mass m downward by a distance h. So the option can be clearly seen that it is third option. Okay, so the next question that we have is as follows. We have to find out the work done in moving a body of mass 4 kg with a uniform velocity of 5 meter per second for 10 seconds on a surface which is rough. It is rough because they have mentioned the coefficient of friction mu 0.4 and g is 9.8 meter per second square in the question. So let's see. First, let's draw the diagram and let's deduce all the information that we can from the given diagram. So this mass is of 4 kg. Therefore, there will be a downward force of 4g and g is 9.8. So 4g will give us 39.2 Newton. 39.2 Newton. Then there will be a normal reaction in the upward direction. Let's call that normal reaction N. Now I'll just erase out this Newton wala N, otherwise it will create a confusion. So normal reaction, so there is no vertical motion, therefore we can easily write down normal reaction is 39.2, and let's assume that the motion is towards right with a constant velocity of 5 meter per second. Now obviously the surface is rough, therefore there will be friction, and since the body is moving there will be kinetic friction, and since the body is moving towards right, the kinetic friction will be towards left, and that kinetic friction is nothing but mu n. We have been given the value of mu, so kinetic friction I'll calculate over here, mu n, which is 0.4 into 39.2, and if we do the calculations, it comes out to be 15.68 newtons. So the kinetic friction that we get in this question is 15.68 Newton. Okay, so now it is given that the movement is with a constant velocity. So velocity is towards right, friction is towards left. Obviously there will be a decrease in the velocity of the body, but we have to avoid that decrease. Therefore we have to apply a force in the right hand direction which will balance friction, and since the right hand force is balancing the friction, the velocity will remain constant. So to maintain a constant velocity, the new force that we have put on this body acting towards right must be equal to the kinetic friction, and its value comes out to be 15.68 Newton, which we have already calculated. Now they are asking us to find out the work done in moving a body with a constant velocity. That work done is nothing but the work done by this force, because the right hand side force is opposing the friction and cancelling out the friction, which is giving net acceleration 0, and the velocity then remains constant. So what we have to actually find out in this question is nothing but the work done by the capital force F. Okay, and that will be nothing but F into S into cos theta. So force is towards right, displacement is towards right, and therefore the angle between them will be 0 degree. So it will be F into S into cos of 0 degrees, and that will be nothing but Fs. So if we substitute the value, it will be 15.68 into S. Now the only thing that remains is calculation of S. So we have to calculate S over here. So let's calculate S over here. Now displacement can be written as S is equal to ut plus half at square. But since the forces are balanced, acceleration is 0 and displacement is simply ut. So velocity is 5 meters per second, which is constant. Time is 10 seconds. So displacement comes out to be 50 meters. So in the place of displacement, we just have to substitute 50, and the answer will be 15.68 into 50, that is 156.8 into 5. And the answer comes out to be 784 joules. It comes out to be 784 joules. You can just do the calculations. It's a pretty simple calculation, and we can see that the option is